Hello students, today we are going to start another chapter of your book, that is Gravitation. The objective of today's topic is to study about the gravitational force and acceleration due to gravity, under which we are going to discuss about gravity and gravitational force, acceleration due to gravity, Newton's law of gravitation and gravitational constant. So let's start our chapter. Gravitational force. The force of attraction between any two masses in the universe is called gravitational force. For example, here we can take an example of two balls. The force of attraction between two balls, two stones, is called gravitational force. Whereas gravity, the force of attraction between the earth and any other body lying on or near its surface is called gravity. Now it's clear difference between gravitational force and gravity. Gravitational force is also termed as gravitation only. Next is acceleration due to gravity. If you remember, acceleration is rate of change of velocity. It means that rate of change of velocity due to gravity is acceleration due to gravity. Let's see its definition. The acceleration produced on a freely falling body by the gravitational pull of the earth is called the acceleration due to gravity, and it is denoted by small g. We can see here, initially if ball is falling freely under the effect of gravity, at 0 seconds its velocity is 0 meter per second. After 1 second its velocity becomes 9.8 meter per second. After 2 seconds its velocity becomes 19.6 meter per second. It means that after 1 second, one more 9.8 get added into 9.8 meter per second. Similarly, we get that after 3 seconds, its velocity becomes 29.4 meter per second. Means again, after 1 second, 9.8 meter per second is added in 19.6 meter per second. It means that after every second, velocity of this ball increases with 9.8 meter per second. So, we get that during each second of fall, the speed of a ball changes by 9.8 meter per second. The change in speed is due to gravity. Hence, the acceleration in this case is called acceleration due to gravity, and its value is 9.8 meter per second square, which is constant for Earth. We should keep some points in our mind. Number 1, when body falls vertically downwards, G is taken as positive. When body is vertically projected upwards, G is taken as negative. And the value of G is different at different places on the surface of the Earth. Although we have a constant value of 9.8 meter per second square for Earth, but its value varies from equator to poles. So, value of G is different at different places on the surface of Earth. Now, the very important law, that is Newton's law of gravitation, which is also termed as Newton's universal law of gravitation. According to the law, every particle in this universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Let's see. Consider two bodies with mass m1 and m2 separated with the distance of r from their centers, and F1 is the force of attraction by m1 on m2 and F2 is the force of attraction by m2 on m1. Then F1 is equal to m2 because both the bodies are attracting each other with the similar force, which is equal to g m1 into m2 upon r square. Let's see how this relation comes. According to this law, force of attraction is directly, you can see here, directly proportional to the product of their masses. F is inversely proportional to the square of distance between them. Combining these two equations, what we are getting? F is directly proportional to m1 m2 divided by r square, which gives us F is equal to g m1 m2 upon r square. To remove the sign of proportionality, we put a constant of proportionality, which is capital G. Now it is very important. G is constant of proportionality and it is called gravitational constant. Its value is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. It is one of the most important value you have to learn and you have to keep in your mind. And it is called gravitational constant. Since it is called gravitational constant or universal gravitational constant, its value never changes with place and time. Now, gravitational constant. Now we will see detail of gravitational constant. Students, if m1 and m2 both are unit masses, means both are equal to 1, and distance between them is also unit, means distance between these two bodies is 1, then if we put all this value here, m1, m2 and r, we'll get that F is equal to g, which means that we can define gravitational constant as gravitational constant is numerically equal to force of attraction. This is force of attraction. G is numerically equal to force of attraction between unit masses separated by unit distance. Unit means 1. When we take m1 and m2 1 and r also 1, means distance between them is also 1, then G is numerically equal to force of attraction between two bodies. So, list of all the fundamentals of universal gravitational constant or G in brief. These are some fundamentals of gravitational constant which you have to keep in mind and you have to learn, and it's very important. You must learn this table. Now, universal gravitational constant, its symbol is G. We have another definition similar to this definition only. The force of attraction between two objects with unit mass separated by unit distance at any part of this universe is called universal gravitational constant. Nature of value, constant at any point in this universe. As I already told you, that universal constant value is a constant value, it never changes with place and time, and its value more accurately is 6.67408 into 10 raised to power minus 11 Newton meter square per kilogram square. But you can also round it off up to 2 decimal places and it comes out to be 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. Now, important one, dimensional formula. Dimensional formula of gravitational constant. Most of the times, this dimensional formula comes in your exam. It is m raised to power minus 1, L raised to power 3 and T raised to power minus 2. And last is SI unit. It is Newton meter square per kilogram square. So, this is a table of gravitational constant, and next is difference between capital G and small g. We have learned both the things. Capital G is gravitational constant, whereas small g is acceleration due to gravity. Now let's see what is the difference between these two quantities. Capital G. G is the universal gravitational constant, whereas small g is acceleration due to gravity. G value is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square, whereas approximate value of small g is 9.8 meter per second square. Value of g varies from one place to another on the earth. Last point is constant throughout the universe. Its value remains constant throughout the universe. Small g changes every place on a planet. Example, on the moon, the value of g is 1/6 of that of the earth's surface. Okay. So these are the points of difference between capital G and small g. Now you are able to answer all these questions. Question number 1. Define gravity and gravitational force. Question number 2. What do you mean by acceleration due to gravity? Question number 3. State Newton's law of gravitation. Question number 4 is G is called the universal constant. Why? And it is one of the important question. What is the difference between capital G and small g? And last one is numerical. A 50 kilogram mass is standing near another 60 kilogram mass. If the distance between them is 1 meter, calculate the gravitational force of attraction between them. I am going to give you a hint. Here two masses are given, m1 and m2, and distance between them r is also given. You have to find gravitational force of attraction. You have to find the value of F. G is not mentioned here. You have to learn the value of capital G. So that's the end of the topic.